Hello and welcome. My name is Carl Palmer. I work at ACCESS under the Education portfolio, and today I'd just like to take you through this brief slideshow presentation. It's about 10 to 15 minutes, looking at our flagship education program, which is called the Habitable Planet Workshops, or for short, the HPW program. Before I start, I wanted to just take a look at the reason why we've come to Sanlam. The Sanlam philosophy for sponsorship states that we believe that great sponsorships are built on bold ideas and sustainable relationships. And the reason that we've come here is to Sanlam is because we believe we have one such bold idea. And we call that idea Habitable Planet. And principally, Habitable Planet is a novel and progressive initiative that seeks to reposition the threat of climate change as an opportunity for transformation, for personal development, and for economic development. Ultimately, we see it as an opportunity for nation building. What I'm going to show you today is that the philosophy of the Habitable Planet is derived from a variety of observations and things that have emerged. Firstly, on a global scale, we have the emergence of a new kind of science, so-called Earth System Science, and that stems from the emergence of systems-level thinking. I'm going to just touch on that. Then I'm going to look at how South Africa is special in this story. Firstly, in terms of the people and our priorities, how we might have a different perspective from that of, for example, someone from the UK or the US. And then secondly, I want to look at why South Africa is different in terms of the resources that we have. And one resource in particular is the quite incredible and diverse physical environments that Southern Africa has to offer. And then last, I want to highlight the need for us to reach and to inspire with the story of science people that wouldn't normally consider themselves as scientists. And principally, out of all of that, we've come up with this Habitable Planet workshop. And it's a workshop that's targeted at undergraduates, and it's had a huge impact. And I want to show you quite how important it's been to the students that we've had come through the program. But it's limited in terms of its scope, in terms of the numbers that we can get through, and also in terms of it being targeted just at undergraduates. And we have plans that we could do so much more with this idea. So to understand where the Habitable Planet workshops have come from, we first need to start with this global understanding of a new type of science. And this new type of science emerges from an epistemological shift, a way in which we understand, a change in the way in which we understand how we understand things. And it's called systems understanding. And in order to sort of illustrate that, I want to go right back to this photo taken in the moon landings in the 1960s. And the reason I show this, apart from it being a stunningly beautiful photo, is to illustrate how systems understanding first arose. And it really arose in the public's imagination to start with, before being adopted by science. And it arose because of this photo. By looking at this, for the first time, human beings were able to conceptualize and see for themselves that the Earth is an isolated system hanging in space. Everything that ever happens on Earth, and ever has happened, from human affairs to trees being cut down to marine life, is all happening on this one isolated system hanging in the blackness of space. And it is an isolated and closed system. Everything that we've got has to be recycled. Everything is interrelated and needs to be considered as such. And that really, it started the birth of the modern environmental movement. But moreover, it started the birth of this idea of systems thinking. Now, scientists have been quite slow to catch up on this. If we want to understand how a complicated system like the Earth works, it's crucial for us to understand how all the different components work together. But science tends to be fragmented by discipline. We don't really work together well as chemists and oceanographers on the one hand, or for example, biologists and physicists on the other hand. These disciplines tend to specify and tend to work in silos. And so it's been now identified that this is one of the main things that's holding back our understanding of how the Earth functions as a system. And I want to just use an analogy to illustrate this reasons why we're failing so badly with understanding the Earth by drawing comparison with another very complicated system that we work with regularly. And that complicated system is the human body. And if we have a look here on the slide, you can see that we all have an understanding that there are very, very many different specialisms when it comes to understanding the human body. So for example, we know that we train heart specialists and liver specialists and psychologists and lung specialists, but we also have this concept of medicine. It's an overall systems understanding of how the body works. We all know how your heart, your liver and your lungs all contribute together to making your body function. And most importantly, we teach children about it. So if I told you to go to your son or grandson or granddaughter or cousin who's sort of 6 years old and explain to them why you have a heart and a liver and a lungs, you would have no problem with that. And through educating children and through educating everyone about how this complicated system works, but breaking it down into systems thinking, into understanding the relationships, we've achieved great things. The average life expectancy for a human being has somewhere between doubled or quadrupled in the last 200 to 300 years. That's an incredible achievement. And it doesn't come down so much to training the experts, but training everybody. Because we understand how our bodies work, we want to wash our hands before we eat, because we know that we don't want our body invaded by germs, for example. But when it comes to an understanding of the planet, we know that we train chemists and oceanographers and physicists, but we don't have this overall systems understanding, this medicine, if you will, for the planet. And if I told you to go to your 6-year-old grandson or granddaughter and tell them about oceanography, you'd think I was absolutely crazy. And so Earth system science provides us with this medicine for the planet. It's the systems level understanding of how the Earth functions. So I hope there, in the first section, what I've done is I've illustrated the emergence of Earth system science and illustrated the need for Earth system science when it comes to solving big Earth scale problems. And I'm sure that all of you watching this video will be aware that the biggest Earth system problem that we're facing as a species at the minute is that of anthropogenic climate change. What I want to try and do in this section is illustrate the problem of anthropogenic climate change as being the big Earth systems issue, but to also show that actually for the majority of South Africans, whereas climate change may well be one of the biggest problems facing them, it might not be the most important, and I want to try and show you why. The first important point is to be very clear that the temperatures recorded, the average temperatures of the planet, are increasing, and they are doing so at a rate which is unprecedented in history, and it looks now to be very clear. The words on the screen say very likely, but this is actually from an older IPCC report. It is now, I think, almost certain that this increase, or most of this increase, is due to the release of what's called greenhouse gases by humans. So we are causing the climate to warm. The IPCC publish all sorts of predictions on this and do various modelling activities, and here just to show an example, on the left hand side we have the various emission scenarios, how much greenhouse gases we're going to emit, whereas on the right we can see how that is predicted to affect global temperatures. And we can see that in all of the scenarios we expect to see a rise in global temperatures. Now, coming from the UK, it's tempting to think that that would be great, that we'd get some more beach days and that we would all be able to sit around in the sun like the Spanish. But unfortunately, that's not what it means, because a rise in temperatures, or not what it necessarily means for everyone, a rise in temperatures overall, of course, also affects areas that are already too hot, but also it means that there's more energy in the Earth's atmosphere, and that means more intense storm events, more droughts, more floods, more strong winds, more hurricanes, etc. And that obviously has both an environmental and an economic cost. It also means rising sea levels, which has an economic cost, and This greenhouse gases are acidic, so it also is contributing to making the oceans more acidic, with implications for marine life. And the really important thing from that right-hand side graph is to see that in all but the most optimistic scenarios, we would cross the +2 degrees margin within this century, somewhere in the later half of this century. Now that's significant because nearly all scientists agree that after the 2-degree mark, we hit a turning point where it becomes very, very difficult to turn back, and where very, very nasty things start to happen. So most scientists are agreed we need to avoid that 2-degree warming to prevent catastrophic climate disasters. And that's looking to happen some point in the next century if we carry on as we are. And at the minute, most efforts to abate climate change seem to have failed. So the situation sounds very alarming, and it indeed is. It's a crisis of global proportions, and one which is probably the most pressing facing the world generation growing up now. But in South Africa, we have some other problems, and I want to frame them by looking at this. This is a study commissioned by a quite infamous statistician from Denmark, a guy called Bjorn Lomborg. Bjorn Lomborg wanted to look at how do we prioritize between the problems that are facing the world today. And he wanted to know, from economists, in solving which problems, what do we get the biggest return on our investment in terms of abating human suffering, in terms of improving the material conditions for human beings on Earth. So he assembled a group of economists to try and answer this question, and included within that group 2 Nobel Prize laureates. So it's 17 of the world's best economists. And they were asked to decide on which are the most pressing problems facing the world, and they included everything, as you can see, from disease and malnutrition to climate change and to water and sanitation. Nothing too surprising there. However, what's very surprising for us, particularly as a climate scientist, is to look at how they rated the possibility of solving these problems. So what return on your investment do you get? If, for example, you had $1 billion to spend on one of these, how would you abate human suffering the best, most effectively? And climate change, as you can see, comes absolutely bottom. For every dollar that you spend on trying to prevent human suffering by preventing climate change, you get the least return on your investment. Whereas, come to the top of the table, and this is what's really interesting, narrowing down to a local perspective. At the top of the table, we have the control of HIV and AIDS, malnutrition and providing micronutrients, subsidizing trade, and the control of malaria. Now, these are issues, particularly HIV, malnutrition, and malaria, that impact South Africans severely today. And so this study provides us with some interesting food for thought about how particularly poorer people in South Africa might think differently. Do we want to prioritize the needs of the future over the needs today, especially when we can see that we get a much less return on the needs of the future? Moreover, when we try and think about the climate predictions for the next 50 and 100 years, principally what the models say is that in 50 to 100 years' time, we might have a bunch of severe problems related to climate, including floods, droughts, refugees, and those associated medical conditions with hot or cold or wet conditions, diarrhea, pneumonia, and fires. But when you think about South Africa today, we have all of those problems. In Cape Town, every single year, when it starts to rain in winter, the townships will flood and people's homes will be washed away. So it's a very confusing message for young South Africans to say that we should be terribly concerned about all these things happening all these things might happen in 50 years' time, when they're all happening today. And for those people who grew up in the townships, they experience these problems on a daily or seasonal basis. To put it in numbers, this graph, I think, very nicely illustrates why we might expect people growing up in South Africa today to think differently. If you look at annual deaths each year, we have 10 million deaths from easily curable disease. This is a facet of poverty. These diseases could be cured if we just had the resources, the finances to do so. 10 million a year. Then we look at air pollution. Now most of this is due to indoor wood smoke. It's people who don't have electricity. Now that's 5 million a year. Then look on the right hand side of the graph and we look at climate change. Climate change isn't even in the millions. And this is not climate change, this is all climate related deaths. We've got two estimates there, a lower one which is just the direct deaths and a higher one which includes all the indirect effects from diseases, etc. And you can see that the numbers of people who are affected currently by climate related disasters and die as a result are absolutely insignificant compared to the ones that are dying principally due to underdevelopment, due to economic disadvantage. And those ones on the left-hand side of the chart, those are what affects young South Africans today. Those are pressing issues that affect young South Africans today. The solution, or the obvious solution to these, is for cheap energy. And of course, cheap energy comes from burning coal. But we have the threat of climate change on the other hand. If we look at the right-hand side, if we're going to burn more cheap coal, we're going to expect those deaths on the right-hand side to come up. So my point here is that there's a really interesting moral dilemma between the needs of the present and the needs of the future. And it's a moral dilemma and it's a political, not a scientific problem. The scientific problem has been answered. We know that the climate is warming and we know that it's caused by humans. What we do about it is a political problem and it has to be weighed up against other priorities. And in order to make that decision, we need to have informed discussion. And our solution in South Africa may well be different to Europe and the rest of the world. We have a different perspective because of our different level of development. So having got you thinking about what I hope you think is an incredibly complicated and difficult moral dilemma to solve, I want to now resolve that with one very eloquent solution. What I want to argue is that all of the problems that I've outlined, from the climate change to the lack of development, can be solved with one solution, and that's to educate more scientists. And let me just examine that a bit. When we say more scientists, we've got to think, well, where are they coming from? Now, if you look at the throughput of scientists, which I'll show in a minute, when we look at from affluent schools, we do very well at getting young people to be scientists. So if we're going to train more scientists, what we're going to need to do is to attract people to science who wouldn't otherwise have been inspired or know much about it or envisaged being a scientist. And that's really those people in South Africa who are at a significant economic disadvantage, who don't go to the good schools and the good universities. We need to inspire them to want to become scientists. And that becomes a journey that is through a personal development. It gives them a career that they would not before have chosen, and a very, very well paid and exciting and interesting career we can offer as scientists. But it also helps solve the economic disadvantage problems. All of those problems that I looked at can be solved if we can stimulate the economy. And the South African government is committed to this transition to the knowledge economy. To transition to the knowledge economy, to become richer, we need scientists, we need innovators, we need people who can think. So we can solve those problems on the left-hand side of the last graph I showed, because training scientists can ultimately help economic development. It's a personal and on a national level. But then the climate change problems need climate scientists. We need people to be able to ask and answer the sort of scientific questions around the climate change problems. We need Earth system scientists. So if we can educate more scientists, we can hope to solve both problems. But there's an issue. When we look at how things stand at the moment, we're failing to get scientists through to the research level. We're not getting those people who are going to drive the knowledge economy and who are going to drive the solutions and the understanding of the climate system. And what I'd like to contend is one driving force behind this, one reason why we're failing, is that telling students for whom the present is unacceptable, that the future is likely to be worse than today, is not going to inspire them. If you're trying to hook students into Earth system science by telling them in 50 years' time we might be experiencing all the things that they know as their everyday, every year reality, it's not an inspiring story to tell them. So putting together all of that I've now introduced as the background, what we need to do if we want to inspire more students is to think different. And what I'd like to contend is that here in Southern Africa we have a massive advantage over the rest of the world when it comes to attracting students to science, because we have this unique and diverse physical environment. This just illustrates some of the ways in which the South African environment is absolutely unique in the world. And in each of the cases, it's unique because of its diversity. So if we look at the top right, for example, we look at the oceans surrounding Southern Africa. One ocean on the west coast is a jungle. It's colder water, it's more nutrient rich, lots of life. The ocean on the other coast, however, is a desert. The Southern Ocean below us is in between the two. We have all the extremes around our coasts. If you look at the same picture, you can see chlorophyll A on land as well. So the oceans are showing chlorophyll A, the land is showing chlorophyll A. And you look around Africa, some countries have jungles, some have deserts. South Africa is half and half. Again, we have the incredible diversity. We've got diversity, for example, in our plant life. We have our own floral kingdom just within the Cape region. We have the Big Five still running free. So when it comes to zoology, again, we have this incredible diversity. And pretty much everywhere we go through the story of why planet Earth is habitable, South Africa turns out to be exceptional through its diversity. And so what we try and do is build a picture for the students of an extended rainbow nation. So we try and build a philosophy around the fact that we all are cognizant of the idea of the rainbow nation, that strength arises through diversity of culture. But what we do in Habitable Planet is just show that culture forms just one small part of a much bigger picture of strength through diversity, which goes from a diversity of oceans to diversity of biology to diversity of geology, through to culture being an important part of that. And so in the Habitable Planet course, we've basically posed the question, can we inspire more, particularly disadvantaged South Africans, to take an active interest in science through selling this story about South Africa being the most unique and special place to do it? And we came up at the start with these principles that, as I just said, we wanted to promote a philosophy that the Rainbow Nation doesn't just extend to people, but it's the people are a smaller part of this big story. And therefore, we want to inspire students with science, not by telling them that the future is going to be worse, but by telling them that they actually live in the most incredible part of the world to be an Earth system scientist. We aim to use this to democratize science, to make it something that's open and inclusive, and ultimately the concept is to try and inspire young people to solve both of those problems that I presented in the background. What would we do? Well, we take undergraduate students for 10 days, and the reason we call it Habitable Planet is we explore what are the reasons that the planet is habitable. And in doing so, we come to the inescapable conclusion that South Africa is incredible and unique in this story, but we also learn about a systems perspective, because in order to understand why the planet's habitable, we have to learn about all those different systems. A little bit like the learning that we get at school about our body, we're just doing it for the planet. And this slide shows a synopsis of what we call the core part of the course, and we basically go from very, very simple physical models at the top. The very, very top lecture there is called Not Too Hot, Not Too Cold. And in that top lecture, part 1, we consider would the Earth be habitable if it was a ball of rock the right distance from the Sun? You can make a very simple observation. Venus is too hot, Mars is too cold, maybe Earth is just right. And it turns out with such a simple physical model, the Earth should be far too cold. So we have a model that we understand, anyone can do the calculations, but the model is wrong. But it's useful. All models are wrong, some are useful. This one's useful because we know the assumptions that go into it. And then what we do throughout the course is we gradually add layers of complexity to the question. So if it's not just a physical model with a bare rock, what else do we need? Well, we need an atmosphere. But then we find that we need an atmosphere that moves. We need an ocean. We need an ocean that circulates. And then we find that you can't just take a static picture of the Earth. You need a paleoclimate perspective to understand the current. Then we come to the strange realization that you can't explain why the Earth's habitable without bringing life in. And lastly, we look at the evolution of humans, how they've arisen with, and the links to climate and how humans arose, and then what humans are doing now in terms of industrialization affecting the climate. And that comes in just at the end of the course, which is quite a divergence. Rather than start with the problem itself, we build the understanding of the planet that's needed to engage with Earth system problems, with any Earth system problems for that matter. And at every point along the way, we stress why South Africa is special and why the students are so lucky to be studying this discipline in such an incredible part of the world. To help illustrate that, we have a strong emphasis on field trips. We spend at least 3 days of every 10-day course going out in the field, seeing iconic examples of why South Africa is special in this story. And moreover, to make this story accessible and to try and appeal to young people, we get young people to tell the story too. So I get alumni from the course to tell all of this story of these core lectures, to go each one adding their specialism, whatever their research is in, or whatever they studied, to add to this story. So we get young people to teach other young people. We tell a story that's relevant, that's about South Africa and exceptional, of the exceptionalness of South Africa and in South African environment. And we do it in a way which builds the knowledge tools and builds critical thinking in order to be able to engage with Earth system problems. I want to show we've been doing this now since 2008, and this just gives you a flavour of some of the more recent groups that have been through. We've got through to about 800 graduates of the programme now. And we're able to show that it has a real impact. So this graph shows how many students go from their current level or from their previous level of study to the next. So how many go from honours, then from undergraduate, then do an honours? How many go from honours and then do an MSc? How many go from MSc and do a PhD? In the blue, we see the Habitable Planet students. In the red, the national average. As you can see, Habitable Planet students are about twice as likely to go on to the next level towards being a research scientist. And we've now extended the programme by empowering the graduates from the Habitable Planet workshops, the undergraduate students, graduates from our workshops, to go back to schools and try and spread their newfound enthusiasm for science. Now this didn't come from us, this came from them. When they finished the workshop, they were inspired to want to do something to give other people a flavour of why they were now so excited about science. And a lot of them came to me and they said, well, it's great that you've had this intervention and that we're now excited about science, but I wish I'd seen it before. So we're now empowering them by funding them to go back to their schools and run something similar with their schools. We've now done one with the University of Pretoria and one with the University of Venda in rural Limpopo, where our alumni, they call themselves Planeteers, have gone back to their schools and tried to inspire other young people with their message. So what I've tried to tell you today is that we believe we do have an exciting and bold idea. It's called the Habitable Planet Programme. It's born out of the observation that the average South African may well have a different perspective on climate change than the one that's presented by the mainstream. And that the South African environment is incredibly unique in its diversity. Taking those together, we can think about an alternative perspective that would help inspire young South Africans with a love of science. And it's centred on why Southern Africa is this unique location to be a scientist. So far we've run it with undergraduates and it's been an incredible success. We've had so many inspired students. We've also done a trial programme and a pilot study at running it and sending those undergraduates back to schools, and this we feel has been effective too. And that's really the story so far. I just want to leave you with a few of the quotes from the students that have been through the process.